Putting bits in is the other thing though you'll want to know. And if I were going to put in one of these router bits, this is how you do it. I'm basically feeding it into the collet. You'll feel it bottom out, and what you'll want to do is just tighten it up slightly at that point, but then pull it out slightly. You don't want it making contact with the bottom of the base there. And then tightening these up, this is pretty typical of most routers. You have 2 wrenches because there's 2 nuts here that turn against each other. So what we're going to do is just get the wrenches on, tighten the bit. This you want to do pretty firmly. You can do most of it by hand and then use the wrenches. Get a bit tightened. Okay. Now, depending on whether you're using a plunge or a stationary router, the next step involves adjusting the heights, and that's different on each of these. This is the more complicated machine, and the way that you would set the height on this machine is that you can use this little turret system over here. This is a way to gradually take material at successive depths out of the wood. One of the limitations of routers, as opposed to maybe using a table saw dado blade, is that you can't take out the full amount probably that you want at once with the router bit. So for example, with a 3/4 inch bit, if I need to go a 1/2 inch into the wood, I'm not going to do that all in one pass. Usually the rule of thumb for router bits is that you only want to take half of their width in depth at any one time. So for a 3/4 inch bit, that means my upper limit is going to be 3/8 of depth in one pass. I only want to go 1/4 inch at a time. How do you do that? That's what this turret system is for. It lets you plunge down to an initial height when you hit this, when you hit the top turret, and then you can rotate over to the other one for your next pass, plunge down a little more. And these are graduated at different heights, and you can customize it, but the ones I have it set at are, these are offset by 1/4 inches, and then it goes down 1/8 and then another 1/4. So depending on how deep you're going into your wood, you just keep going down in successive rotations of this turret. So the only work to do at the beginning is setting the initial height, and that's basically involves loosening that bar so that it can move freely. I'll plunge down until I hit the wood. That's my 0, because I'm at the level of the wood. So what I want to do is to set my 0 I'll be on the top turret for that one. That's going to be my 0. So I'll let that sit there, lock the bar, pop back up. Now I know if I go from there to turret number 2, when I make this plunge, I'm going to be going down a 1/4 inch from the top of this wood, and only a 1/4 inch. And so that's the goal of the plunge router turret mechanism. It just controls the depth of how much you can go in each pass. Now actually operating this is very simple. There's a power switch up here, and all these routers are slightly different, but this model has the power switch in the top. It has a lever which enables the plunge to happen, but you can see it's spring-loaded. So while this lever is out, it'll just spring back up if I don't let go. If I let go of the lever down here, it stays. So the typical way of operating this is turning it on, and you always have the face shield towards you. Turn it on, plunge down to your cut, let go of the lever so it stays down there, make your cut, and then plunge back up. Now, the fixed router is even simpler because we don't have to do any plunging. It's the same principles apply with regard to putting in the bits. You get it in there, you feel it bottom out, and you want to pull it up slightly from there. Not very much. You want as much as that shaft to be in there as possible to reduce vibration, but you just don't want it bottomed out. Okay, we'll tighten that up. Now, with the stationary router situation, we don't have the option of plunging. We have to just set this at a height, and in this case, if I'm trying to do what this router is doing, I'm going to have to set the exposed amount of this bit to be a 1/4 inch, because that's the maximum I want to go in a pass, right? So I'll set this to be a 1/4 inch. It's very hard to set these just by eye with a ruler or some other, there's a lot of other jigs you can use, but always test on a scrap piece before you go to your final piece. All right, so let's say I think I have it about right, a 1/4 inch. And now I can do my routing. So if I wanted to make a slot starting from the end of a piece of wood and going in, I'm all set. If I do my slot, then I have to go back and in order to go deeper, expose more of this and do another pass. So the only other thing to be concerned about with routers is you need to understand the rotation of the bit. This determines which direction you're going to push or pull the router, and it has a big impact on the performance of the router and the quality of your cut. Basically what's happening here is in the router, we've got a bit spinning clockwise as you're looking down on it. So what this means in terms of cutting wood is that when wood is making contact with this router bit as it's spinning, if I bring the wood in, or if I bring the router bit into the wood rather, because we're using handheld, I'm going to want to have some pushback from the wood onto the router bit. So if I'm spinning this way and I come into the wood from the left, the wood is actually going to push back because, as you can see, these cutting edges, the silver part here, the cutting edge, are actually digging out the wood, and the wood is going to push back on the bit. Now, the opposite, if you're coming from the opposite direction, which is this way, what's happening is I'm pushing the router this way, and the bit is actually pulling the wood into the cut. So it's grabbing the wood and pushing it in the same way that I'm going. It creates a very unstable kind of cut. It can catch the wood in weird ways. And so when you're doing this kind of cut in the wrong direction, sometimes you can't avoid it depending on the orientation of the wood, but you generally want to be coming from the other direction. So you always think of it this way. You're going to always want to be going from left to right on the wood. So the router bit orientation and the way it's spinning are important with routers, and we'll see that on the router table as well.